Yes, I'm going to talk a little about mobility prediction and resource allocation and what can potentially go wrong in these kind of systems. But I will start on a more general level overview of the problem. We have heard very nicely today that we want to see better utilization of computing resources and network resources. And that's a key area for Swedish industry, not at least, that have a long tradition in the telecommunication area. And to AI and autonomous principles allows us to better utilize our networks and computing resources. But as we've also seen here today, that comes with lots of challenges. We have seen the historical overview that Ahmed gave this morning of how we worked with platform security. We have strong needs to verify the resources we use before we actually put computing on them. We need to make sure that we isolate the computing tasks that we put on common resources and try to avoid leakages. And that's very challenging for traditional systems. We have been working for a long time with attestation protocols, verification of virtualized systems, and so on. But now when we come to more and more autonomous systems, the challenges become even greater, and the security problems will also increase. So that's what I'm going to specifically go into a current example to show what kind of issues we can face when we try to optimize the system and make better utilizations of the resources. And the example I'm going into here is a new standardized function in the global network systems from 5G and on called Network Data Analytics Function, NWDAF. And that's a function that allows you to utilize the traffic data and the mobility data you collect from mobile users from the mobile networks globally, and that the network operators can use to optimize their own networks, but also third parties can utilize this functionality to offer better services to their customers. And then you have a function that makes analytics on your traffic and you try to optimize it. So the network operator, for instance, can try to optimize the performance and get better response time from the network to their users. And in order to do so, you need to predict where you will have congestions, where will the users be that utilize the network, how long time will they stay in a cell, and so on. And what does that mean from a security perspective? That also means new angles for attack, because you need to rely on this traffic data. It must be trustworthy. You must be sure that only honest users are in the system, maybe, or you need to make your analytics models more robust. What are the potential threat angles here? For instance, the mobiles are typically controlled by sometimes honest users, but sometimes not so honest users. There are open APIs in the network functionality that could be utilized by attackers. And what does that mean then if we do more mobility prediction to get better resource utilization? Here, to give one example that we have looked into, you can as a malicious user, try to insert strange mobility patterns. And this picture shows one example here, where you take a control over two mobile units and then maybe able to clone them. There are examples that you can clone the identity of a mobile, and then you let them turn up at one point in time, at one slot, at one base station, and then in the next you are in another one, and then you jump back and forth and so on. That's a quite unexpected behavior. And what would that mean for your resource allocation function? Or you can move, like we have seen people trying. We discussed before here earlier today. We also heard a talk on Google Maps, and that you can fool the traffic jam functionality there. And then one way of doing that is also examples of that is to take a crowd of mobility units and let them slowly move over the system. How could that potentially influence it? And if we would do that for an mobility and time slot predictor, what would happen? We see here, that's what this figure shows here. The upper purple line shows the effect of this crowded attack, and that will not affect the predictor at all. But if we do a jump, where we take, for instance, a couple of mobile units and let them jump up and forth, we see that the more mobiles we control in the system. Here's an example from 0 up to 200 in a system with overall 10,000 units. Then the prediction accuracy drops dramatically. With just this simple tuple jump attack. And That's, of course, also easy to detect, and that's what we have also shown for some example systems, that you can easily take away and block these things and disregard them from your analytics results. But anyway, it clearly shows that when you design a new system, when you do resource optimization, you also need to account that malicious behavior will affect it, and you need to make your system more robust. So with that little simple example, I would just like to conclude what I would say here, that these advanced resource mechanisms that we see will come in the future networks, that are huge opportunities, give better resource utilization, but we also need to make sure that they are robust, and we need to spend more efforts in preventing malicious behavior and make them system reliable so that we really can trust them. And with that, I will end this talk.
Thank you. What are the most crucial effects on the threat landscape of the public sector, would you say?
It depends a lot on the applications. What we talk a lot about autonomous vehicles, drones, and things like that. And these are, of course, very sensitive to. They will be dependent on fast responses and reliable. And these kind of systems could have very severe effects if they are not working properly, of course. So that I think one quite obvious example.
Thank you.